Hi guys, this is Math 116 and we're moving on to Chapter 2. This is section 2.1 and all about quadratic equations. So I'm going to give you the bullet points of this section in this video. The first thing to keep in mind is how to identify a quadratic equation. So quadratic equations are equations where the highest exponent has a 2. So anything that's x squared plus something can be a quadratic equation. Obviously it doesn't have to be x, it can be y or z or whatever. It just has to have a squared component. So the general form of the quadratic equation looks like this. ax squared plus bx plus c equals 0. And a has to be greater than 0. So this is never going to be ax plus b. It's always going to be something like 3x plus whatever, minus 4x plus 21, something like that. So there will always be numbers here, but this coefficient a has to be greater than 0, because if it was 0, then you wouldn't have a quadratic equation anymore because this whole piece would go away. So this a greater than 0 piece is just telling you that you have to have an x squared piece there. So one thing you will learn in section 2.2 is that the general form of a quadratic equation, this always graphs as a parabola. So we're going to go over the graphing of it more in section 2.2. In this section, we want to solve for x. That is, we want to find the values of x so that this general form is true. We want ax squared plus bx plus c to be equal to 0. And we want to find out which values of x make that true. And there's essentially 4 different ways to do this. There's factoring, there's the square root method, which I find kind of boring, so I made a average meh face there. Graphing method, which can be helpful if you're good with your graphing calculator. And finally, the quadratic formula. I'm going to go through an example of each one of these to give you a sense for what they are talking about. So the first one here is a factoring example. So this is question number 5, and this is the 10th edition textbook. This one was not in the 9th edition, but I liked it, so I can see why they put it in the 10th edition. The question reads like this: x squared minus 4x equals 12, and it says solve by factoring. So on a test I might say solve by factoring. I guess that's not the craziest thing in the world. Sorry, it's taking me so long to write factoring. So the first thing you want to do is write the equation in the general form. That is, essentially set it equal to 0. We do this by subtracting 12 from this side, because the 12 is kind of the guy who's on his own over there. So if we subtract 12 from both sides, this side now equals 0. So what we can do is we want to say what values of x make this equal to 0. So we're going to do the reverse FOIL method, factoring. This is why we did this in chapter 0, is to practice factoring. Or maybe it was chapter 1. So again, a little review of factoring. We have 12 and we're trying to factor this. So if you said, well, 12 times 1, that equals 12, but the difference is 11, and we want a difference of 4. Okay, how about 6 times 2? Ah, good, the difference is 4. Hooray, we're done. So we want minus here, minus. So we have x minus 6 and x plus 2 equals 0. And they can FOIL method that. That's x squared plus 2x minus 6x, that's minus 4 minus 12. Okay. So in order for this all to equal 0, we need x minus 6 to equal 0. So you add 6 to both sides, and that tells us we need x to be equal to 6. And we need x plus 2 equal to 0. X equals negative 2. So those are our solutions. The trick with these factoring things is anytime you have something times something equal to 0, if any one of these is 0, then that's a solution. Because if you had 0 times some big complicated thing, that's always going to be equal to 0. So the way you solve these is you factor, and then you let each piece equal 0 and solve. So here's our solutions. X equals 6 and x equals negative 2. So that's solving by factoring. You can always check your answers, right? You can plug this negative 2 back into the equation to make sure it equals 12, right? That would be 4 minus, that would be negative 2 times 4 is negative 8. Does that equal 12? Yes. 4 plus 8 equals 12, etc. So that's how you can check your answers on these. I also, very cleverly, graphed this one for you. X squared minus 4x minus 12. You can graph it like this on your graphing calculator, or if you're at home on your iPad, you can use a graphing app. So there's negative 2 and 6. And you'll notice the zeros are the places where where the graph crosses the x-axis. So it's not where x equals 0, it's where y equals 0. Aha! X equals negative 2, x equals 6. What did I get? Negative 2 and 6. How awesome is that? I think you guys think that's pretty awesome. Don't save. So now I'm going on to the next example. So remember this. So we did factoring. The square root method, I think you're going to be a little underwhelmed by the square root method, but I will go through an example of that one also. Here's one. This was maybe a little clever, I guess. This is question 21. Again, this is the 10th edition. I did not check to see if that one was in the 9th edition. I think it might be, though. X plus 4 squared equals 25. So if you're going to solve this by the square root method, you can take the square root of either side, right? Take the square root. And remember, when you take the square root, so now we have x plus 4. We took the square root of that. This is going to be plus or minus 5, because the square root of 25 is two things. It's 5 and it's negative 5. So the trick here with taking the square root is you have to remember that you get two solutions, plus or minus. So now, to get this, you subtract 4, and so I get x is equal to, for plus 5, I'll write plus 5 minus 4 is equal to 1. This is kind of a stupid way for me to write it, but you could do it this way. If you did negative 5 minus 4 equals negative 9. So we have two solutions here, right? We have 1 and negative 9. And we can put these in to check, right? If you put 1 in there, you get 5 squared. That equals 25. Check. Put 1, x equals 1. And if you let x equal negative 9, that should be an equal sign, you get negative 9 plus 4 is negative 5 squared is also equal to 25. Huzzah! We got it. So our two solutions here are x equals 1 and x equals negative 9. So that is an example of the square root method. Square root method. Okay? So, factoring. Square root method. Maybe you liked it. Maybe I should take that away. Maybe you liked it, huh? Graphing. So the graphing solution is when you graph it into your calculator, like I did, and then you look for the places where it crosses the x-axis. So we're going to do more of this in section 2.1. So I'm going to breeze over that one for a moment and then move right to the big guns, which is the quadratic formula. Quadratic formula is so popular in math, you guys. It's one of the few things that essentially all mathematicians and math students have memorized. And there's a nice little song that goes with the quadratic formula, which I may sing you in a moment. So the quadratic formula will always work for these problems. So if you're thinking, I don't know which of these methods to use, you can always use the quadratic formula. I'll go back to it here for a second. So here's what you're memorizing. For this, if it's in the general form, ax squared plus bx plus c equals 0, I'll copy that and paste it here, right? If it looks like this, then, sorry, I'm just trying to get rid of that 5. It's driving me crazy. Oh well. Then you have the solution, x. There's two solutions, negative b plus or minus square root of b squared minus 4ac all divided by 2a. And the little song goes like this. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. That's the Pop Goes the Weasel song. There's a nice video with the animated weasel that I will also send to you. You can watch that. So here's an example of how to use the quadratic equation. Here's one I like, is the quadratic equation. So suppose you have this problem. This is question number 31 on the 10th edition textbook, which is also number 29 on the 9th edition. So if you have the 9th edition, this is question number 21. If you have the 10th edition, it's 31. And the problem says solve for x. And we have x squared equals 2x plus 6. All right, so If you just had this on a test, you wouldn't know necessarily to use the quadratic equation, but the first thing you would do is you would get everything on one side, so you're putting it into the general equation. So you subtract the 2x, we're bringing everybody over here to that side of the party. Minus 6 equals 0. Nobody's on this side of the party. So now it's in the general form. You could try factoring, but you're not going to get anywhere. I happen to know this because I saw the answer and it doesn't factor. So, or suppose you just don't like factoring and you don't remember how to do it. Now you can use the quadratic equation. In this case, a equals 5. That's our a, that's the coefficient of the x squared. B equals negative 2, and c is equal to negative 6. You have to be really attentive to the negative signs because they're going to make a difference. So our formula, x equals negative b. I'm going to make a different color here. Negative b, b is negative 2, plus or minus square root. The song is stupid, but it may help you remember it. So b squared is negative 2 squared, right? Minus 4 times a times c, which is negative 6. Do you see how the negative signs are just going to be there snapping at your heels? And all over 2a. Oh, excuse me, yeah, 2a. 2 times 5. So now we just have to simplify. I'll go back to yellow. So x equals 2, because that's negative, negative, right? Plus or minus the square root of 2 squared, that's 4. And this is 20 times negative 6, so that's negative, what is that, 120, but then it's negative, negative, so it's plus 120, all divided by 10, which is 2 plus or minus square root of 124, all divided by 10. And at this point you might be a little bit puzzled and think, well, I'm done, and I would accept this, but I want one more, so I might take off 1 point unless you do the following. I want you to reduce this a little bit, and what you can remember is that the square root, kind of play with it in your calculator for a second, and 124 is 4 times 31. So really this is equal to 2 times the square root of 31. And I just messed around with this. I divided it by 4, I divided it by 9. I was like, 4 works. So you have 2 plus or minus 2 square root of 31, all divided by 10. So your answer is, I'm running out of space, it's 1 plus or minus, you factor out the 2 and cancel, square root of 31, all divided by 5. So you have 2 answers, 1 plus square root of 31 and 1 minus square root of 31 divided by 5. I'm going to graph this one for you also, and you can see. Hold on. So here's the graph of that one we just solved. 5x squared minus 2x minus 6. So it's a parabola. And again, this is too much information, but because this 5, see how that's greater than 0? That means the parabola opens up. So we'll get into that in the next section. And there's the 2 points. Negative 0.914 and 1.314. But Kate, didn't you just say it was 1 plus or minus square root of 31 over 5? Yeah, if you put that in your calculator, you get minus 0.914 and 1.314. I would accept either one of those, so you don't have to leave it in this form. All right, and I have one more application for you. I just wanted to show you where we were here. So I showed you, here's the general form, ax squared minus, it should be plus bx plus c, right here, general form. Showed you how to factor the square root 1, the graphing solution where you graph it and look for the places where the graph crosses the x-axis, right? Crosses x-axis. Okay. And finally, the quadratic formula. You should definitely be able to use the quadratic formula. This will always work for every problem. If you don't want to mess around with these, you can always plug the numbers into the quadratic formula. So here's one final example that is a bit of an application. Don't save. So this is question number 45, which is also 43 in the 9th edition. Oops, I want a paintbrush. So question 45. 10th edition, and it's question 43, 9th edition. This is an application problem. It reads, if the profit from the sale of X units of a product is P is profit, you guys. Everybody likes profit. That's the money you get to keep, is equal to 90X minus 200 minus X squared. That's the profit, where X is the number of units, right, that you're selling. They say, what profit, what level of production, units, sorry guys, units, what level of production will yield a profit of $1,200? We're basically saying, what is the X value that leads to a profit of 1,200? So we set our profit function equal to 1,200, 90X minus 200 minus X squared, and we solve for X. So we say, okay, the first thing to do is put it in the general form. I'm actually going to bring everybody over to this side because I like having a positive X squared. So I'm going to rewrite this as X squared minus 90X, because he went over to that side. So you add 200. So that becomes plus, he was already over there, 1,200 was waiting for us. We had 1,200 plus 200 equals 1,400 equals 0. So this one, you could use the quadratic equation. You could let A equal 1, B equal negative 90, and C equal 1,400. But I'm a little bit lazy and I just saw that this factored right away. 1,400, I thought, well, 14 reminds me of 7, so 70 times 20 will give you 1,400, and the difference there, if you subtracted both of them, you'd get negative 90. So I saw the factoring right away, but you can always use the quadratic equation. X minus 70 and X minus 90 equals 0. So if you're looking for the places where this equals 0, you let this one equal 0, that gives you X equals 70 as a solution. You let that one equal 0, and that leaves X equals 90 as a solution. So these are the two places where it will make a profit of $1,200. Personally, were this my business and I could make the same profit by making 70 items versus 90, I would just make 70. But obviously this is not necessarily the exact question. So this is the answer to the problem. What are the two situations that yield a profit of $1,200? X equals 70 units and X equals 90 units. Ta-da! And you could also see that by graphing. You could graph, ching, you get 70 and 90. This is a terrible graph. Okay, so work these quadratic equation problems. I have a couple of videos about how to program your calculator to do the quadratic formula, but it's a little tricky, so you might not want to bother. All right, keep me posted with questions.